Hi there, this is a video lesson for Algebra 2, Chapter 4, Section 2, when we are solving quadratic equations by graphing today. So we're going to get started with some examples. It's probably the easiest way to explain most of this to you. When you're solving a quadratic equation by graphing, you'll notice that the quadratic function part, the quadratic term, linear term, constant term, are all equal to 0. Normally, you would have it equal to y. It would say something like y equals x squared minus 3x minus 4. And then what they've done is they've replaced the y with a 0. And if you remember, whenever you replace the y with a 0, this is basically the x-intercept. So we are looking for the places on the graph where the, on the coordinate plane, where the graph would cross the x-axis. We know, for example, that parabolas generally look like this. So we would expect it to cross in two different places. And what we're trying to do is find the two places where it crosses. We want those x values. So that being said, because sometimes when we graph using the method of 4.1, which is to graph only 3 points, that might limit us when we're trying to actually find the x-intercepts. So in the case of that, you're really going to want to be able to use your calculator, because you'll want to be, otherwise you'll have to plug in the values for your t-table constantly, and you don't want to have to do that. So for this example, what we're going to do is we're going to make a table of values. And the first thing you want to do is to, because we know that the graph is symmetric, we want to find where that vertex is. So of course we do that negative b over 2a. So x equals negative b over 2 times a. And in this case we get 3/2. Or 1.5. So over here on my table, I have 1.5. Now if you have a calculator, you can actually type this portion of the equation, the x squared minus 3x minus 4, into y1 and graph it, and it'll have, I don't want to get close here, it'll have the graph right there. And what you want to do next is use the second trace. So you want to hit the second button, and then the trace button, which basically has a calc feature on it, and then you want to hit option 1, which will give you a value. So once you've done that, what you should see on the lower left-hand corner of your screen is an x equals that's blinking. And what you can do now is type in 1.5 and hit enter, and it will tell you that the y coordinate is negative 6.25. Okay? Now what we want to do, because now we know where the vertex is, we want to pick points that are around 1.5, centered around there. So we talked about this in our last lesson. This is a fraction, so I don't want to stick with the fraction. So I'm going to go ahead and pick 1 and 2. And the number 1 is a half unit away from 1.5 to the left. And the 2 is a half unit away from the 1.5 on the right. But it means that I don't have to pick fractions anymore. So I'm going to pick 1 and 2. And then I'm going to pick 0, negative 1. And over here I'm going to pick 3 and 4. Alright, so see what's going to happen now is the only way to fill the table is to plug in all these numbers into your equation and get the y value. But that's why we're using the calculator. So if you do the second calc thing again and you hit value, you can actually type in all these numbers, negative 1, enter, and you get 0. Type in 0 and you get negative 4. Type in 1 and you get negative 6. Type in 2 and you get another negative 6. 3, negative 4, and 4, 0. you should see the symmetry when they're equidistant. They're both -6. These are both -4. These are both 0. See? So remember, what we're looking for is the ordered pairs that have the y-coordinate 0. So we have identified those now. Y-coordinate 0 there, y-coordinate 0 there. So you don't actually have to draw the graph itself. You probably should for your homework because they're going to be looking for that. But you can tell from here that the two solutions are x equals -1 and 4, because those are the two places where the y-coordinate was 0. And that's how you solve by graphing. So now we're going to let you do this. Now remember that in part A, you have everything the way it should be. It's equal to 0. In part B, it's not equal to 0. So remember that you have to bring the -12 to the other side before you can begin. All right. So now here we want to talk about solutions of a quadratic equation. Like I said earlier, normally we fall into this realm where we draw the parabola and it pretty much looks like it's going to cross in two places. We got two answers in our previous example. But these other two options are also available. And the first one is when the parabola kind of sits on the x-axis, so it only has one solution. And then of course there's the case where the parabola never actually crosses the x-axis, so in that case you have no real solutions. Later on in the chapter we'll talk about this scenario because those are called imaginary solutions. But for now there's no real solution, or there could be two real solutions, or there could be one real solution. So our next example, again doing the same thing. Now remember that this is another case where it's not in standard form, so the first thing I have to do is put it into standard form. So you want to move the 6x to this side and put the 14 over, I'm sorry, I don't want to do that. I want everything to be on one side, but I do want it to be in order. So what I'm going to do is I'm going to say, okay, -x squared from here. I'm adding the 6x, and the 14 was already there, and I still have the 23 over here. So then I'm going to subtract the 23 to the other side. I get -x squared plus 6x minus 9 equal to 0. Okay, so now what I want to do is, again, you want to basically type this equation into your calculator in the y equals menu. -x squared plus 6x minus 9, and we are going to hit graph. And again, we are going to try to come up with a t-table. And to do that, we want the vertex, so we're going to take -b divided by 2 times a, which is -1, which gives us -6 over -2, which is +3. So there's my 3 for my vertex. If I do the second calc 3, when x equals 3, y equals 0. Now at this point, you don't really have to go any further. If you don't trust what you're doing, then you can keep going further. But what just happened is, and is something that I don't know if you can tell or if you notice right away what just happened, but from right off the bat, the vertex is our solution. That's the place where the y-coordinate is 0. So there aren't going to be any other zeros because the vertex is the smallest point on the graph, and as we said earlier, it's basically going to be one of these scenarios, this scenario here, and there's no other options. So now if you don't trust what you're doing, you can proceed to do what we've said in the past, which is to pick points that are around 3. So you could pick something like 3, 4, 5, 6, maybe pick 0, 1, 2, and again go to your calculator, do the second trace value feature, type in 0, you get -9, type in 1, you get -4, type in 2, you get -1, type in 4, and you'll see the symmetry happening here, -1, type in 5, you'll get -4, and then type in 6, and you'll get -9, and you can see the symmetry shown here. But the only place where you get the 3, 0, or the y-coordinate 0 is the vertex. So this is a case where you only have one solution, and it's x equals 3. So anytime your vertex ends up being the y-coordinate 0, then you know that you have a situation where you have only one real solution. Okay, so now we're going to go, I'll let you do this do-it-yourself question. And then we have this bit of a word problem here, but it's not really that complicated. It says use a quadratic equation to find two real numbers with a sum of 15 and a product of 63. So the easiest thing to do here is to just call the two numbers x and y. You can say x is the first number, y is the second number. And if you have a sum of 15, that means that when I add my two numbers together, they're going to equal 15. And a product of 63 means I'm going to multiply my two numbers and have a product of 63. Okay? So now, when I look at that, I can't have two variables in my equation. So now you can just use some really easy substitution. You can solve for y by subtracting x. And it turns out that the second number is y equals 15 minus x. And so when you look at your product equation, you can go x times y, but y is 15 minus x, equal to 63. So now you're going to get 15x minus x squared. So x times 15, 15x, x times negative x squared, equals 63. And to put it all into the right order, you have negative x squared plus 15x minus 63. So I'm going to bring the 63 to the other side and then put it in the right order. So the negative x squared goes first, plus the 15x minus 63. And now this is my equation. And again, we're going to do a little t-table to solve this by graphing. So I'm going to get negative b divided by 2 times a, which is negative 15 divided by negative 2. So I get positive 15 halves, or 7.5. So we're going to put 7.5 over here. And again, you go to your calculator, you want to plug in the negative x squared plus 15x minus 63 in your calculator, and then graph that little guy. Ooh. Ooh. Okay, so now I'm going to go second trace, and I'm going to type in 7.5, and it turns out that I get negative 6.75, which is not 0. So far, I'm not convinced that it's not going to have a solution. There's only going to be one solution. It's not going to be one real solution because this is not 0. So now I want to pick numbers that are around 7.5, and I'm going to pick 8 and 7. 7 is a half unit away from 7.5, and 8 is a half unit away from 7.5. So we're going to pick 7 and 8, and we're going to pick, let's see here, 6 and 5, 8, 9, and 10. So when I do my second value thing, I get x equals 5. It is going to be negative 13. 6 is negative 9. 7 is negative 7. Then we have negative 6.75. 8. And you can start seeing the symmetry. So we expect 9 to be negative 9, and it is. And we expect 10 to be negative 13, and it is. So this is the only one that I'm actually going to graph so that you can see what's happening. I'm going to erase some of what I have here to make space for my graph. But basically what's happening here is I am like at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And I'm going to go over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. just to give you an idea. 1, 2, 3, 4, 5. When x is 5, it's negative 13, way down here. 6 is negative 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere right there. 7 is negative 7. So 1, 2, 3, 4, 5, 6, 7. And then in here we're going to get negative 6.75. And then at 8 we're going to get negative 7. At 9 we're going to get negative 9. And at 10 we're going to get negative 13. So what you're going to see, okay, and my graph is not that great, but this is what you should be seeing right now. All of these values, including the one in the middle, these are all negative. None of them are positive. So what's happening here is that this graph is never actually going to cross the x-axis at all. So basically, this is not even possible. It's not possible to find two numbers that add up to 15 and at the same time have a product of 63. That doesn't mean that it won't always work. And I can tell you right now that you have to do the do-it-yourself question here. And just so that, in case you're thinking that it's not going to work, it will work in do-it-yourself number 3. You will actually find the two numbers that work. And just because this one didn't happen to work, the one that you were given will actually work. And you set it up much the same way, but when you actually make your t-table, it's not going to be like this one where it doesn't cross the x-axis. It will cross the x-axis, I promise you. So, do-it-yourself number 3 for you. And then we have our last example. And in this last example, it says solve x squared minus 6x plus 4 equals 0 by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. So again, we're going to make sure that we type in this equation, x squared minus 6x plus 4, into my calculator. And I'm going to make my little t-table. And I want to find my vertex, so negative b divided by 2a. It's going to be positive 6 divided by 2, which is 3. So I put my 3 over here. I do my second trace value feature. X equals 3, y equals negative 5. And then I pick numbers that are around 3. So maybe like 0, 1, 2, 3, 4, 5, 6 sounds good. And notice that I get negative 5 here. This is not a case of one solution. And so now I'm going to test the other values. When x equals 0, I get 4. When x is 1, I get negative 1, 2, negative 4. And then again, you can see the symmetry here. When x is 4, you get negative 4 again. So they're symmetric. I should expect when x is 5, it will be negative 1, and it is. And that when x is 6, it will be positive 4, and it is. Okay, so what we're seeing here is that we've already tried all these numbers, but none of them have y coordinates of 0. But that isn't enough to tell us that I don't have to keep going. What should tell you that you've got to keep going is the fact that you changed from positive to negative. Right about, in other words, the difference between, right here in the middle, from negative 5 to negative 4, they're both negative. Negative 4, negative 1, both negative. Negative 1, positive 4, there's a sign change there. It went from being negative to positive, which means somewhere in between 1 and 0, the actual y value will equal 0. Also change the sign right here. Negative, 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 and it all of a sudden went to positive. So it says here, if exact roots cannot be found, so we're not going to find the exact x values, but then it says if that's the case, then state the consecutive integers between which the roots are located. So we know that the roots are located between, one of them is between 0 and 1, because it changed from negative to positive there. And the other one, and also between 5 and 6. And that's how you estimate the roots. Now, we're going to learn a way to actually find those roots when you come to class. But I want you to try to do what you've done before in much the same fashion. And again, like I said, we're going to do, there are 2 more examples in your textbook, examples 5 and 6, but they require some things with a calculator that I need to show you how to do with the calculator. And so we will not be doing those in the video today, but we will be doing them in class. So have no fear that we will get to those. So once you have finished this do-it-yourself question, you will have completed your notes for today. And I will see you in class, and thank you for watching.